What if time, the relentless river we all float down, suddenly stopped for just 1 second? A single, solitary second frozen solid. It sounds like something straight out of a superhero movie, right? A cool power to have, a moment to catch your breath, maybe even pull a harmless prank. But what would really happen to you, to the world, to the entire universe, if everything just paused? The reality is far more chaotic and mind-blowing than you could ever imagine. Forget a peaceful, silent world. A 1-second time freeze would be the most cataclysmic event in history. So, buckle up, because we're about to dive into the physics of a frozen moment. And trust me, it's going to get wild. First, let's define what we mean by time stopping. Are we talking about a magical freeze where everything just holds its pose? Or are we talking about the fundamental laws of physics ceasing to operate? Let's explore the more magical scenario first, the one you see in movies where a hero can move through a frozen world. If time stopped for everyone and everything but you, you'd instantly be plunged into absolute darkness and silence. Why? Because light particles, photons, would also be frozen in place. They wouldn't be able to travel from objects to your retina. Sound waves, which are vibrations traveling through the air, would also stop dead. You wouldn't see or hear a thing. It would be like being in the most profound sensory deprivation tank ever conceived. But it gets worse. You wouldn't be able to move. To move, you need to push against something. In this case, air molecules. But if the air molecules are frozen solid, they would be an immovable wall. Trying to walk would be like trying to push your way through a block of concrete. Every molecule in the air would be locked in place, creating an impenetrable, invisible barrier all around you. You'd be trapped, blind, and deaf, suspended in a frozen sea of air. And what about breathing? Your diaphragm couldn't contract to pull in air because the air molecules wouldn't flow. Even if you could magically move the air, the oxygen molecules would be static. They wouldn't diffuse across the membranes in your lungs. So, within that 1 second, you'd be suffocating in a world full of unbreathable, frozen air. It's not looking so super anymore, is it? You'd be a statue, aware but utterly powerless, for the duration of that one eternal feeling second. Okay, let's get even more scientific. What if time stopped for asterisk, everything asterisk, including you? Not just a pause for the world around you, but a universal halt. Let's say at the stroke of noon, every clock, every atom, every quark in the universe just stops for 1 second. From an outside perspective, if such a thing could even exist, it would be as if that second never happened. The universe would just skip a beat. At 11 hours, 59 minutes, and 59 seconds, everything is normal. Then, an instant later, it's 12 hours, 0 minutes, and 1 second. The intervening second would be completely erased from the timeline. We wouldn't know it happened. The universe would just continue on, 1 second poor, but completely unaware of its loss. It's a bit of a philosophical dead end, because if no one can experience it, did it even happen? But the truly fascinating and destructive scenario is if the asterisk concept asterisk of time, as in the T in physics equations, went to zero. This is where things get really explosive. Let's start with momentum. Momentum is mass times velocity, which is distance divided by time. If time stopped, even for an infinitesimally small moment, your velocity would become infinite. Anything with mass that was in motion on, that's everything in the universe, from spinning electrons to orbiting planets, would suddenly have infinite momentum. Think about the Earth. It is spinning at about 1,000 miles per hour at the equator and hurtling through space around the sun at 67,000 miles per hour. If time stopped, the planet would instantly try to be everywhere at once along its path. The kinetic energy, which is proportional to the square velocity, would also become infinite. The result, the Earth and every other moving object in the cosmos would release an infinite amount of energy. The planet would vaporize in an explosion of unimaginable power. Not just the Earth, but the Sun, our solar system, and every galaxy would detonate simultaneously. The universe would become a uniform, infinitely hot soup of energy and fundamental particles in less than a blink of an eye. That 1 second pause would effectively trigger a new Big Bang, wiping the slate clean. And what about the forces that hold everything together? the strong nuclear force that binds atomic nuclei, the electromagnetic force that holds atoms together. These forces are mediated by particles that travel at the speed of light. If time stopped, these messenger particles, gluons, and photons would freeze. The forces they carry would vanish. Atomic nuclei would fly apart. Electrons would abandon their orbits. All matter would instantly disintegrate into a chaotic cloud of subatomic particles. It wouldn't even have time to explode from the kinetic energy issue. It would simply cease to exist in any recognizable form, even if we ignore the catastrophic energy release. Think about gravity. According to Einstein's theory of general relativity, gravity is the curvature of spacetime caused by mass and energy. The spacetime part is key. Space and time are intrinsically linked. You can't just stop one without fundamentally breaking the other. If you stop time, you break space. What happens to gravity then? Does the fabric of the universe just flatten out? If so, the moon would fly off in a straight line. The Earth would leave its orbit around the sun. The entire structure of the cosmos, held together by the delicate dance of gravity, would unravel. Galaxies would fly apart. It would be complete and utter structural failure on a universal scale. So, let's step back from the brink of universal annihilation. What if it was a more localized, magical time? Say, just a bubble around you where time flows normally, but it's frozen outside. You could walk around, sure, but as soon as you step out of that bubble, you'd slam into the frozen wall of air we talked about earlier. And what happens at the edge of this bubble? The boundary between flowing time and frozen time would be a place of bizarre and deadly physics. Air molecules from your bubble would smash into the static molecules outside, creating immense heat and pressure at the boundary. Your little time bubble would likely be a glowing, superheated sphere. You might be safe inside, but the edge of your reality would be a literal firewall. Furthermore, light from the outside world would stop at the boundary of your bubble. You'd still be in darkness, looking out at a frozen snapshot of the world. But here's a weird thought. What if you had a flashlight? You could shine it, and the photons would travel within your bubble. When they hit the edge, they would stop. You could essentially paint with light onto the inside of your time bubble, creating a static image that would hang there until time resumed. Weird, right? But let's think about the end of that 1 second. What happens when time restarts? The consequences would be just as devastating. Imagine a car moving at 60 miles per hour. It freezes. When time restarts, its atoms suddenly have to go from 0 velocity to 60 miles per hour, instantly. This instantaneous acceleration would be infinite. The forces involved would tear the car, and anything in it, to shreds. Now apply that to everything on Earth. The air molecules, which were chaotically bouncing around, would suddenly resume their motion. This would create a sonic boom of epic proportions, originating from everywhere at once. A global thunderclap that would deafen anything that could hear and shatter windows worldwide. The thermal consequences are also dire. Heat is the motion of atoms. During the freeze, all atomic motion stops. The universe would effectively drop to absolute zero temperature, or 0 Kelvin. When time restarts, all that motion comes back. But would it come back perfectly? Any slight imperfection in the reboot could lead to catastrophic temperature shifts. Regions could spontaneously become incredibly hot or cold. And remember our infinite energy problem. When time restarts, all that potential for infinite energy suddenly resolves. The transition would be unimaginably violent. It's like the universe holding its breath and then exhaling with the force of 1 trillion supernovas. So, the next time you wish for a moment to stop, maybe think twice. Whether it's a magical pause or a scientific halt, stopping time for even 1 second would unleash forces beyond our comprehension. It would plunge you into a blind, silent, suffocating prison, or it would obliterate the entire universe in a flash of infinite energy. Our reality is woven from the fabric of space-time, a fabric so delicate that pulling a single thread, even for a second, would cause the entire tapestry to unravel. Time's constant. Forward march isn't a limitation. It's the very thing that allows for existence itself. It's the beat that keeps the heart of the cosmos ticking. Thank you so much for joining me on this mind-bending journey today. If you enjoyed unraveling the mysteries of the universe with us, Make sure to hit that like button and subscribe for more deep dives into science and speculation. What other what-if scenarios should we explore? Let me know in the comments below. Stay curious, and I'll see you in the next one.